Are we rolling?
Yeah.
What's the topic? Molecules. Molecules are everywhere. They're in your body, in the food that you eat, in the air that you breathe, and the clothes that you wear. What exactly constitutes a molecule depends on the field of study, but from a biochemical perspective, molecules are charged or uncharged groups of two or more atoms held together by chemical bonds. Now, a fundamental tenet of biochemistry is that structure determines function, but structure also determines a molecule's properties. Molecules have a myriad of different properties, but for the sake of these videos, we're going to focus on solubility and photochemical reactivity. In nature, organisms, including humans, employ molecular machines to produce large quantities of structurally similar but chemically distinct molecules, much like an assembly line can efficiently furnish large quantities of related products. These molecular machines produce both individual molecular units and multi-unit macromolecules. So let's look at a couple of molecules. Glucagon. 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 What's a glucagon? This. Wow, that's repulsive. Yep, sure is, but don't worry about all that complexity. Look at the pattern, and look at the chain down the middle. Now, look at this guy. Any guesses what it is? It's heroin. And do you see a pattern in heroin? Well, there's an O over there and an N right there. And O comes after N in the alphabet, so yeah, no pattern. So you can guess which one of the two molecules is synthetic. That's heroin. Molecules are water-soluble when there's charge separation within their structure. This often occurs in molecules that contain alcohols, carbonyls, or amine groups, to name a few. Finally, molecules that have conjugated double bonds have the ability to absorb light. Molecules that can absorb light are photochemically reactive, which means that they are likely to break when exposed to specific wavelengths of radiation. Now, we've gone over three basic features of molecules that will be extremely important to be able to identify when looking at their chemistry and specifically when applying them to pharmaceuticals.
Yeah. Let's go, come on. Yeah. Yeah. They say I'm cooler than cool.
That I'm the best of the best.
Cause they know that when I do it, I'ma do it to death.
See, I be taking their breath.
Cause they know that I'm fly.
You couldn't be as fresh as me, so tell me why would you try?
Could it be in my walk?
Or maybe it's in my talk.
They know that when the roof is burning, that your boy was the spark.